Hi, I am using MacBook Air M2 right now. And when I wanted to transcribe my 20 minutes video, it used to take 12 to 14 minutes because I was using Whisper. Now I made it 3 times faster. And this video is all about how I made it 3 times faster. So let's get into it. The simple reason is that I'm using NVIDIA's Parakeet TDT 0.6p V3 version. So it is as accurate as Whisper, if not better, but it is similar, and it is accurate in English, in my opinion. And these are the European languages which you can see is supported in particular language. And if you want any other languages apart from this, you can always fall back to Whisper. So I am making an desktop application in which I am using this. So actually, I have used Parakeet before this implementation, but it was not fast as it is today. So you can see I made a video 3 days ago. I found a Whisper alternative that actually faster and free. So I made this video, and in this video I talked about how I was using in Electron, in React, how I was using Parakeet. So that had one problem, and that was I thought that in WebGPU uses the GPU of the system, but it is not true. It uses GPU of the browser. Like, the browser makes sure that it uses GPU, so it is dependent on browser. But since I was building a desktop application, and when you are building a desktop application, you have the access of the bare metal of the particular desktop or the particular computer. So when I had this particular thing, then why shouldn't I use GPU directly from the system? So that was my thought, and I did it. So what I did, I am already building an Electron application. In that, I had two options actually, and that was I could have created one bridge using Swift, and I think that is, so I can say it is almost done. It is transcribing the 21 chunk, and it is using 2 minutes 29 seconds, 2 minutes 34, and it is finalizing. And I think in the AI subtitles you should see the time. So transcription completed in 2 minutes 34 seconds. So it was really fast, but you can see there is one error, and my RAM usage is almost 6 GB right now, which is actually a problematic scene. Now if I save this one, and if I just save this one as subclip Parakeet web. Let me do this one, and let me save in this name. Now let me do one new, and let me just reload this particular application, because if I don't reload this application, it will stay in 6 GB RAM because it has loaded this one. So I will just do reset, and it will do this one. And if I, so it has found the virtual environment, and now it will actually do the transcription. So let's see and wait for the application to transcribe it. So for the initialization, it took around 19 seconds, and we will just see the progress. 10% is almost done. Like, it is creating the chunks, and we are creating 5 chunks. So it should take less time. And you can see this is the logs, like transcribing chunks, and this is the first chunk it is transcribing, and it is creating 5 chunks. So we will just wait for our application to compile, and you can see the RAM usage as well. It is similar to Parakeet JS. More than that, because it is using again bare metal, so it is using MPS behind the scenes. And we are almost 42% complete. We are processing the third chunk. Like, while recording this, things are pretty fast. I don't know, maybe because of system refresh or what, but yeah, this is really good. And once it is done, we can move back to our implementation of Whisper model, which I will show you the live demo way. And right now, I think it is processing chunk 4, I believe. Yeah, it has processed the chunk 4. No, okay, it is processed. And it has processed it. So we can see it almost took 4 minutes, which I have already talked about. Like, it takes 3 to 4.5 minutes of transcription when I'm using GPU MPS. So we'll name this as subclip Whisper, and you will save this one. And since after the application the transcription is done, you can see in the RAM the electron has gone back to 713 MB. But when it was loaded in the application, it was not going until I have implemented the reload button. So that was really an issue, and that's why I had to move to this one. And sometimes it threw error, but this MPS method will never fail. So that is one of the issue. Now let me just do this new one, and let me just like before trying Whisper, I actually didn't change the Parakeet, so Parakeet was selected by default. So now you can see Whisper is selected. Now we can do start transcription, and it will give us a estimated time. So we'll just wait again, and you can see that when I'm using Whisper, there is no PyTorch MPS available. It uses CPU, and that's why Whisper is slow. If we had used GPU, it would have been more faster. Like if it is taking 12 minutes or 30 minutes, it would have taken less time. Now it is showing 9 minutes 7 seconds because, as you know, all the implementation we did till now, it has shown a tremendous speed. But when system is using a lot of things, it doesn't show that, and I will show you the proof. So let me just close this application, and let me just open one new method, and I will show you all the history. So I was experimenting with the same project, and I will show you when it was taking 12 minutes, when it was taking 9 minutes, and it was 3 hours ago. So again, same video. If I go to AI apparatus, it is 3 minutes 47 seconds. Okay, so while actually testing the application using Whisper and only Parakeet, so I've taken this screenshot. So you can see it took around 10 minutes 22 seconds. It showed ETA like 1 minute 26 seconds, and frame was 171. So it completely depended on the system. And again, same for the transcription completed in 12 minutes 9 seconds. So you can see that it takes around 12 to 14 minutes. Sometimes it took more than 12 or 14 minutes, and yesterday it took more than that, in my opinion. So that was really a problem. And since this was a problem, that's why I used Parakeet. And it is actually Parakeet. The Python implementation, it took 3 minutes 56 seconds. Again, the same implementation, and it took 3 minutes 47 seconds. The same, and the Parakeet Web actually performed well while live demoing. But the concept is simple. If there is load, if there is a lot of apps running behind the scene, because I'm using 24 GB RAM. The point is I'm using 24 GB RAM, and that's why they perform well. But consider that if someone is using 8 GB RAM or 16 GB RAM, then problem will arrive and they will face the problem. And that's why using Metal in the MacBook and using CUDA in the NVIDIA GPUs, that is the better approach, better way to solve this particular problem. And again, as you can see, once the transcription is done, the RAM usage goes to 0 for that particular model. So automatic load, automatic unload happens behind the scene. You don't have to worry. But if you implement the React method, you have to load this application. That creates a problem, and that is what it all matters. And I have created this video again, almost 20 minutes long in recording, so I will edit it. And tomorrow I will show you my launch strategy, which I did on Twitter, and how much sales I have got. I will update you on this particular application. And at the same time, what responses I have received in Twitter, like by just sharing on Twitter. So I will share my experience tomorrow. So stay tuned for that. Until then, take care and bye.